In this lesson, we're going to look at how to prove scalene, isosceles, and equilateral triangles using coordinate geometry. So some formulas that you have to know are the distance formula, slope formula, and midpoint formula. And most commonly for these, we're going to be using the distance formula because the distance formula is going to tell us the length of a segment. And if you remember scalene, isosceles, and equilateral triangles, those are classified by sides. So meaning if you're trying to prove that you have a scalene triangle, it means that you have to have no congruent sides. So that would mean you would find the distance of all three sides and you would see that none of them are the same. If you're trying to prove isosceles, that means you have to have at least two congruent sides. And then for equilateral, you have to have three congruent sides. So what I would want to do if I want to prove a triangle is scalene, isosceles, or equilateral, or classify a triangle by its sides, I have to know how many congruent sides it has. So I'm going to use the distance formula to be able to find the length of a side. So this will give us the length of a segment or side of a triangle. So the process that we're going to do, you're always going to get everything on your graph, draw a label, write your formula that you're using, show all your mathematical work, and then you just have to write a conclusion. So these are not as formal as what we call Euclidean proofs, meaning our flow proofs where we have a bunch of givens, we're making conclusions, using theorems and definitions and properties. And these types of proofs, we're really using our calculations to do so. So we're going to start off with graphing our triangle, but before I do that, let me bounce back up here. So it says, which of the formulas above could be useful in proving that a triangle is scalene? Well, we've already talked about this. So a scalene triangle has no equal sides. So you would want to use distance formula to show no congruent sides. So we've already kind of talked about that. So now when we actually do an example, let's go ahead and plot this. So we have our triangle here. So 7, -1. So 1, 2, 3, 4, 5, 6, 7. Down 1. I have 2, -2. And then 3, 3. Oops. 1, 2, 3, 1, 2, 3. Okay, so there's C. So what I want to do is I want to prove that this triangle is isosceles. So that means I need to show two congruent sides because an isosceles triangle has at least two congruent sides. If it has a third set of congruent, or three sides are congruent, that would mean technically it's still isosceles because it has two equal sides, but it's equilateral, so we would classify it as equilateral. So I just need to show that two sides are equal because as long as it has two equal sides, that means it's isosceles. I don't really care about the third side. So what we're going to do is we're going to write our formula down. So our plan here is to use our distance formula. So distance formula is what I'm going to use. So d equals the square root, the change in x squared plus the change in y squared. And what I need to do is I need to find distance of all three sides, and I need to show that at least two of them are the same. So if I can find two sides are the same, then I don't really have to find the third. But you have to at least find two of them. So you can stop once you find two congruent sides. And then keep in mind, instead of using distance formula, some of you prefer Pythagorean theorem, so you would rather create little right triangles out of these and then use Pythagorean theorem. That's totally fine as well. So let me just put that in parentheses. Or use a squared plus b squared equals c squared. So in order to try to make my life a little bit easier, instead of just picking three random sides or picking a random side to start with, I'm going to kind of look at this and say, well, which sides look like they're congruent, and then start with those, and then if they end up being congruent, then I won't have to do that third side. So I'm just trying to save myself a little bit of time. So when I look at this, I can see that this one was up 1, 2, 3, 4, 5 over 1. So if I was going to use Pythagorean theorem, I would just plug in 5 and 1. And then if I look at this one, it's 1, 2, 3, 4, 5, 1. So again, I could plug in Pythagorean theorem, and that's kind of showing me right away that those are the ones that are going to end up being congruent, because the rate of change from B to C is the same as B to A. Or you could say the vertical and horizontal change is the same. So let's go ahead and use distance formula. So I'm going to choose those two sides, so BC and BA. And like I said, worst case scenario, you don't think about that ahead of time and you just start finding the distances. Well, worst case scenario, you're going to have to find a third distance where your classmates only might had to have done 2 because they thought through it before they plugged in. So it's really kind of your preference. So I'm going to go ahead and plug in. So BC, I'm plugging in my X values. And remember, it doesn't matter which one you start with as long as you're consistent. So I have 3 minus 2, and then I'm going to do 3 minus negative 2. Pay attention to that negative sign, and I just didn't write it as I was saying it. So 3 minus negative 2. And when we simplify, let's simplify in parentheses first. So I'm going to have 1, and then here's going to give me 5. So this is going to give me 1 plus 25. So it's going to give me the square root of 26. So then we'll continue this for the next one. Notice too that I'm labeling which distances these belong to, or which segments these belong to. That's so important, because otherwise you're going to have a bunch of numbers and not know where they belong. So the fact that I'm labeling these is so important, so make sure you're doing that. So I have BA. So I have 2 minus 7 squared plus, and then I subtract my y values. So negative 2 minus negative 1. And again, you can switch the order of these. So I could do 7 minus 2 and then negative 1 minus negative 2. That's fine. So I have negative 5 squared plus, this is going to get added, so it's going to be a negative 1 squared. Make sure you have these numbers in parentheses, because when you square a negative, it's really a negative times a negative, so it turns positive. So make sure you're paying attention to that. So that becomes positive 25, positive 1, which gives me positive square root of 26. Do not forget about the square root. Make sure that stays there the entire time. If possible, you can take out a perfect square, get these in simple spherical form. In this case, I'm just going to leave these as is. And making sure, again, those parentheses, that's so important. Also take a look here. Remember what I was saying about that horizontal and vertical change? I said that they had the same horizontal and vertical change. And you can see that right here, that the vertical change was by, well, in one case it was 1 horizontally, here it was vertically 1, and then the 5 and the 5 for the horizontal and vertical in the opposite directions. So you can really see the numbers, the consistency, which is why in the end the answer is the same. Same thing with, if I use Pythagorean theorem, your side lengths would be 1 and 5 of those triangles. So it's all connected. So now I can see that these two sides have to be the same, because their distances are the same. So that means this triangle is isosceles. So my last step here is to always write a conclusion. A proof is no good unless you actually prove what you were asked to prove. So again, it's not a flow style proof. These are just our coordinate geometry proofs, so they're pretty informal. So we have our math, which is really the proof itself, and then you're just summing it up. So triangle ABC is an isosceles triangle because it has 2 congruent sides. And right here is where I got the congruent sides. So this right here told me that BC is congruent to BA because of the measurements being the same, or the distance between those points being the same. All right, so then the last thing here is your check your understanding. So go ahead and just write down whatever key ideas you have and answer the one question.